right, y'all, so over the past couple days, or really just in this unit, you've been working on understanding similarity. And so we started with using scale factors and performing dilations, and then we proved whether two triangles were similar. And then in lesson 4, we started working towards knowing how to set up proportions of matching up corresponding sides, and then using those proportions that we created to solve for x, or solve for a missing side, or solve for a particular relationship. And so we're going to continue to build on our knowledge and understanding of similarity by looking at some very specific similarity theorems. And so the first one we're going to look at, and the only one we're going to look at in this lesson, is called the side splitter theorem. And the side splitter theorem says that if a line that is parallel to one side of the triangle, so if I know that DE is parallel to BC, so DE is parallel to BC, then I know since DE is intersecting the triangle on both sides, it splits or divides those two sides proportionally. So I would know that if I create a ratio of side AD to DB, so this side to this side, that ratio is going to be equal to this side AE over EC. Now, the reverse or the converse of the side splitter theorem is also true. So the converse says that if a line divides the two sides of the triangle proportionally, so if I know that AD, or the ratio of AD to DB is equal to the ratio of AE to EC. So if I know that these two ratios equal each other, then I can conclude that DE is parallel to BC. So then I could add these parallel line markings in. So we're going to look at 4 problems where we're going to apply the side splitter theorem. So if we look at this first example, okay, I see these arrows here which tell me that these two sides are parallel to each other. So that means that the ratios of side PS to QS are going to be equal to the ratios of PT to TR. And so if I substitute these values in, I have 6 over 2 is equal to 9 over x. And so if I cross multiply, or I could scale up or scale down, whatever works for you, I get that x equals 3. All right, in example 2, it says find the value of x if you know that GK is parallel to HJ. So this one's really similar to example 1. Just notice the only difference is that some of the sides of the triangle are an expression versus just a constant number. And so I can apply the side splitter theorem. So I know that the ratio of FG to GH is equal to the ratio of FK to KJ. So if I substitute my values in, I'm going to have 9 over x plus 3 is equal to 4 over x minus 2. And then for this one, I would definitely cross multiply. So I have 9 times x minus 2 is equal to 4 times x plus 3. So 9x minus 18 equals 4x plus 12. I'm going to do double steps here. I'm going to subtract 4x from both sides and then add 18x to both sides. And so I get 5x equals 30, so x equals 6. And I can stop there because it just said find the value of x. All right, so let's look at example 3. Example 3 says to find x and y. And so, and we are going to assume that these two triangles are parallel. Okay, I know it doesn't say that, but we're going to go ahead and we're going to assume that they are. So on this one, if I try to set up knowing that these two sides are parallel to each other, if I try to set up a ratio, I would get 51 to x, and then the other ratio would be y to 13. And I can't do anything with this because I have two variables, and if I cross multiply, I just get xy equals whatever 51 times 13 is. And so that doesn't really help me. So I'm going to try, and I'm going to separate these two triangles so that I see my small one and then I see the large one. And I'm going to see if I can use what we learned in lesson 4 to help me maybe set up a different set of ratios to solve for either x or y. And so, okay, if I look at this small triangle, I have that this side is 51, this side is 17, and this side is y. And then if I come over and if I look at the big triangle, okay, this whole side is 51 and the x, so this is actually going to be an expression, 51 plus x. And then if I look at this whole side, this is going to be y plus 13. And then the bottom is going to be 21. So if I look at this, now this is going to bring us back to lesson 4. If I look at, like how can I set proportion? And I want to set proportion where I only have either x or y when I set my proportion. And so as I'm looking at this, and I'm kind of focusing on could I do y or could I do x? The first thing that I kind of see is that I could do 51 and compare that to 51 plus x. So if I set proportion, I could do 51, and that matches up with 51 plus x on the other triangle. And then I could create a ratio of the bottom of the triangles, so 17 to 21. And so if I wanted to solve this, now I only have an x. I don't have multiple variables, so I could, at this point now, be able to solve for x. All right, so if I cross multiply, I'd have 17 times 51 plus x is equal to, and then 51 times 21 is 1,071. And then 17 times 51 is 867. Plus 17x equals 1,071. And if I subtract 867 from 1,071, I get that 17x equals 204, and then divide by 17, and I get that x equals 12. And so now, since these two sides are parallel, I could apply the side splitter theorem. I also could go back and I could, I'm going to use a different color here, I could kind of continue with what I did for solving for x. I could set it up the same way in solving for y. Like I could see that y corresponds to y plus 13. And use the bottom of the triangles again, so 17 over 21. And so if I cross multiply, I get 21y equals 17 times y plus 13. And so, and I'm quickly going to run out of room here. So 21y equals 17y, and then 17 times 13 is 221. And then if I subtract 17y from 21y, I get 4y equals 221. And 221 divided by 4 tells me that y equals 55.25. And so I showed you this way where I didn't actually apply the side splitter theorem because sometimes, even though it probably may look like I could use side splitter, I may not need to. I can still use what I learned from lesson 4 instead. Now, if I wanted to, and I am going to go back, I'm going to show you in red. Since I had solved for x and I found that x was 12, I'm going to show it over here. I could apply the side splitter theorem and I'm still going to get 55.25. And so if I set it up using the side splitter theorem, I'd have 51 over 12 equals y over 13. And so if I cross multiply, 51 times 13 is 663, and then 12 times y is 12y. If I divide 663 divided by 12, I still get 55.25. So with that being said, like I said, I can use side splitter. Like side splitter gives me another tool in my back pocket to use, but I can also, there are times where I can just match up corresponding sides and solve for my variable that way. All right, and in this last example, it says that if AC is 60 units, so AC is the entire side. So I'm going to draw a line showing and then write that that's 60. And so the first thing that kind of comes to my mind is I think to myself, okay, well, if AB is 18, 18 plus whatever BC is has to add to 60. So if I do 60 minus 18, which gives me 42, I now know this length of BC. And then over here it tells me that EC is 36 units long. And once again, what comes to my mind is that CD plus 24 has to equal 36. That would have to be 12. So now I've got each section of that triangle where I know what they are, or I know what the side lengths are. So the question says, is AE parallel to BD? That's the question. Well, this is where the converse comes into play. The converse of the side splitter theorem says that if indeed the two sets of sides are proportional to each other, if their ratios are equal, then we can conclude that these two lines that we're questioning whether they're parallel, we'll actually be able to confirm it or say no, they're not parallel if the ratios are equal. So if I use my side splitter theorem, I would know that the ratio of BC to BA has to be equal to the ratio of CD to DE. So if I substitute in my side lengths, I have 42 over 18 equals 12 over 24. And so the first thing that comes to my mind here is how the left side, I have 42 divided by 18. And so that number is going to be bigger than 1. And then I see I have 12 divided by 24. And I know 12 divided by 24 is a half. And if I do 42 divided by 18, I get 2.3 repeating. So these two ratios do not equal each other. So what that means is that side BD, or lines BD and AE, are not parallel because the ratio of the sides are not the same. So if you're asked to tell, are they parallel or not, it's not enough to say, oh, nope, not parallel. Like, explain why they're not parallel. And so like when I show my mathematical work here and I show that the ratios aren't the same, I want to interpret what those ratios mean, or what conclusion will that lead me to in knowing that the ratios aren't the same. So remember, it's not enough to say, nope, not parallel. Give a little explanation to why you've reached that conclusion.